Welcome. Let's look at this example of successive partial differentiation. We've been given a function u, which is equivalent to exponential 3x sine 2y, where x is equivalent to st squared and y is equivalent to s squared t. And we are supposed to find the derivative of u with respect to s and the derivative of u with respect to t. So first we find the derivative of u with respect to s. That will be given by du over dx multiplied by dx over ds plus the derivative of u with respect to y multiplied by the derivative of y with respect to s. So we can compute them one by one. We have the derivative of u with respect to x as we have this function that is function u. So if we are deriving with respect to x, we're going to treat y as a constant, which means sin 2y is not going to change. Therefore, we're going to compute the derivative of this exponential 3x. The derivative of an exponential is given by the derivative of the power multiplied by the exponential. The derivative of 3x is, in this case, is 3. So we are going to have 3 multiplied by exponential 3x and sine 2y, which we have said is not going to change. After that, we go to finding the derivative of x with respect to s. So in this case, we are treating t as a constant, which means I'm only going to find the derivative of s, which in this case will be 1. 1 times t squared will be t squared. I go to the next step, which is finding the derivative of u with respect to y. So we're going to treat x as a constant, which means I'm going to find the derivative of sine 2u. There is a 2, which means we can't just write it as cosine 2y. So we're going to find the derivative of all this multiplied by the derivative of the inside, that is cosine 2y multiplied by the derivative of 2y, that is 2. So this is going to give us 2 exponential 3x cosine 2y, and this one goes under the chain rule, where you find the derivative of all the function multiplied by the derivative of the inside. After that, we go to finding dy over ds. So the derivative of s squared t with respect to s means I treat t as a constant. So the derivative of s squared will be 2s, then multiply by the t. So the next step is replacing those values in du over ds, and after replacing, you're going to get this. So we're going to notice that we can simplify this further. There is t that is common here and here. Exponential 3x is also common, so you're going to factorize out t exponential 3x, and we're going to have this answer. So the next step will be finding the derivative of u with respect to t. So our derivative of u with respect to t is going to be given by the following. So we have the du over dt is going to be expressed as the derivative of u with respect to x multiplied by the derivative of x with respect to t plus the derivative of u with respect to y times the derivative of y with respect to t. Already we earned the values for derivative of y with respect to x and the derivative of y with respect to y. So we are just going to come and copy them here. The only thing that we need to calculate is the derivative of x with respect to t and the derivative of y with respect to t. We have been given our x as st squared, so if we derive that with respect to t, means we treat s as a constant. So the derivative of t squared will give us 2t, and therefore we have 2st. In the derivative of y, we have y as s squared t. So we are going to treat s squared as a constant because we are differentiating with respect to t. So the derivative of t will be 1 by s squared will be s squared. Then we do the same thing, we replace our values, that is multiply du over dx with this one, that is this by this. For instance, if I multiply this with this, I'll have 6 st exponential 3x sine 2y plus this by this will give me 2 s squared exponential 3x cosine 2y. We can factorize whatever is common here, that is we have 2 common in this and this. We also have s as common and exponential 3x. So if we factorize out that, we're going to be left with this, and this is going to be our final answer. So we have computed both the derivative of u with respect to s and the derivative of u with respect to t. This one is the derivative of u with respect to t. I'm so sorry, we are going to change that. So I've already made a correction here. This is supposed to be du over dt, not du over ds. So this is going to be the final answer. Thank you so much for watching. Kindly don't forget to like, comment, and subscribe to my channel.